Hello everyone. In this video we want to continue solving different questions to make sure that you practice more. If you practice more, you will be able to solve this question easily. Let's start with this question. We're still talking about frequency, wavelength, and speed. Question 5 here is talking about you have a wave with with a frequency. The frequency here is given, which is 500 hertz, traveling at a speed, the speed which is 200 meter per second. What is the thing that we want? What is the unknown here, which is the wavelength? How to find the wavelength? For the wavelength here is equal wave speed over frequency. Okay, so this one here, which is equal to, let's write the numbers. You have 500 over the 500, which is this frequency, so it's gonna be 200, which is the wave speed, over 500. So here the wavelength is equal to 2 over 5, which is gonna be 0.4. What is the unit of wavelength, which is meter? Okay, so this is for this one. Let's continue to move to the next one, the next question. For the next question here, you have a wave has a frequency of 540 hertz, and it's traveling at 440 meter per second. This one here represents the speed. Okay, this one here traveling in meter per second here, this is the speed, and this one here is the frequency. I want to find also what the wavelength. So again, the same formula, wavelength equals wave speed over frequency. So here, as you see, if I want to divide 500, which is 340, make sure the numbers are correct. This is the 340, which is equal the speed. Okay, 340 over, which is the frequency here, which is 540. Also here, which is equal to 340, as you see, divided by 540, which is equal to 0.662 actually. The unit for wavelength, which is meter. Okay, so this is for this question. Let's continue. I'll give you another question. In question 7 here, what you have, a wave has a wavelength which is 125 meter, and you have the speed to 20 meter per second. What its frequency? Now, how to find the frequency? If you have the speed and the frequency equals to wave speed over wavelength. Okay, so this one equal to, you have the wave speed, which is 20, and the wavelength here, which is 125, which is equal to 220. Sorry, here you have 20 divided by 125, so which is equal to 0.16. What is the unit? The unit which is hertz for frequency, right? Okay, so this is for the question 7. Let's continue now to solve for question 8. A wave has a frequency. Here you have the frequency is given, which is 900 hertz, and the wavelength, which is 200 a meter. What is the speed? How to find the speed for this one? Here, speed, wave speed. If you have the wavelength and the frequency, so frequency times wavelength. Okay, so here the answer for this one, which is wavelength, which is 200, and the frequency here, which is 900. Okay, so the answer here, which is 180,000. Okay, what is the unit? Meter per second. Okay, so here for this one, for example 8. Okay, let's continue. I'll give you another example. In this example, a wave has a wavelength which is 0.5 meter, and frequency, you have the wavelength and you have frequency, you need the speed also. It's like example 8, wave speed equals the frequency times wavelength. So here, if I want to write the numbers, the frequency here, which is how much? Which is 120 hertz times the wavelength, which is 0.5. So the answer, it's gonna be, you have to remove the 0, so 120 times 0.5, which is equal to 60 meter per second. I want to discuss this one here just to remind you. The frequency number of complete waves passing a point in a given time. If you remember, we send the frequency, which is number of cycles or number of waves over time. And if you have like this a sentence, if 10 waves passes in 1 second, which means what is the frequency, which is 10 hertz, okay? If 6 waves passes in 2 seconds, which means 6/2, which is equal to what? 3 hertz. This point very important, you have to know this one. I'm going to ask you like a question here. I'm going to write a question and I want you to answer it and think about this question. How does the speed at which radio waves travel in a vacuum compare to speed at which sound waves travel in a vacuum? Think about it again. I'm going to write it to allow you to think about it. So look at this question here. Think about it. How does the speed at which radio waves travel in a vacuum compare to the speed at which sound waves travel in a vacuum? Here you have to think about the radio waves. Radio waves are what? Electromagnetic waves, right? So they have the ability to travel in vacuum, and their speed in vacuum, which is constant, which is equal to the speed of light, if you remember. Okay, what about sound? Sound wave cannot travel at all in vacuum because it's a mechanical wave, right? So here, well, let's write the answer. Radio waves, well, let's talk about radio waves. It travels, well, they travel at the speed of light. okay, which is, if you remember, we said the number 3 times 10 to the power of 8 meter per second. I'm going to write the power of 8 just after I finish from this sentence. In vacuum. Okay, هلا sound, which is sound waves cannot, okay, travel at all in a vacuum. Okay, so here I'm going to continue adding the correct answer. 3 times 10 to the power of 8. Okay, so this is here, this number is the same once you say, which is 3, and you have here to put 8 zeros in the front here. It's counting 1, 2, 3, 4, 5, 6, 7, 8 meter per second. This is the speed of light. So this is all about the waves, the properties of waves, how to find the speed, how to find the frequency, what are the relationship between them. If you have any question about this lesson, you can send me your question. Thank you for listening.